Hi, everybody. Welcome back to Shiko Practicing Math Lab, Learning Through Practicing. So in this video, we're going to start our practice number 4. And for the previous 3 practice, we finally finished the sequences. And start at practice number 4, we are going to start the series. So we have 2 topics in this practicing. So the first part here is the partial sum of the series. And then the next ones here, we're going to talk about the geometric series and how to determine the converging or diverging. And if it's a converging geometric series, how do I find the sum of the geometric series? Okay, so this will be the Okay, so here are the problems we're going to practice at this practice. So we're going to have 3 different groups of the problems here. So for the first part of the practice 4 video, we're going to cover the first 4 problems. Then on the second part of the practice number 4, we're going to focus on the geometric series to see how to determine the geometric series is converging divergence. So we have 6 problems we can practice here. Okay, so now as usually, I will advise you, pause the video right now and then go to work on the problem first. And then when you finish working on the problem, come back here and we can check the answer. Okay, so now I'm going to switch to the whiteboard and you can pause the video, and when you finish, just resume the video and then let's try to solve the problem. Okay. Okay, welcome back. I hope that you get a chance to solve some of the problems here. Okay, so like I mentioned, for this practice, the first part of the topic we want to talk about is the partial sum of the series. So let's just do a very brief review and let's see what we have here. So the series, we defined the sequence in the previous 3 practice. We said a sequence is just an array of the different numbers, right? So what is the series? Series is you adding up all these numbers, right? So we say n is from 1 to infinity. So you add up all these numbers. So this is, we call this a series, okay? So if you take a look, if we kind of, so like if I only add up, say, 2 terms here. So if I say, okay, I have AK, and the K is from 1 to 2 here. If I only add up for 2 terms, then what I have here, we call it the partial sum of 2. So the S2 is the partial sum of the 2. So the same ways here is, if you say, hey, if I add up what? I add up 3 terms here. So what do you have here? You have a partial sum of the 3's here. So the same time, if you add up for the K from 1 to n's AK, so if you add up to the n terms, that's what we say, this is SN's here. So as you can see, if I want to find the sum of this series, right? So this series is n from 1 to infinity an. Really is what? Really is like you said, the limit n from n approach to infinity summation k from 1 to n, the ak. That means you just continue adding this a1, a2. So it's what? It's basically is limit n approach to infinity, your partial sum. So if this partial sum have some numbers here, then if it come to some fixed number, so it's 3 or 200 or 300, doesn't matter. If it's come to some fixed number, then we will say what? We will say that this series is a convergence here, right? And what is the conversion to? That means the sum, when you add up, this series will add up to the else here. That's what is we mean, the partial sums here. So if they give you a partial sum, then it's pretty easy. If I want to find the series, I will just add the limit n approach to infinity to your partial sums here. Okay, so let's take a look at the problems here. So basically, we want to get this concept down very good, right? So we said, from the series, well, basically what do we define here? We defined a new sequence. So this is S1, S2, S3, right? So this is our sequence. So what is this sequence about? This is what we call is the partial sum of the series, right? So you kind of change that back to the sequence. So we know if a sequence converge, you take the limits, right? So now the part A is here, the problem number 1, this is the partial sums, right? So that means Sn is equal to 2 minus 3 point A to the nth power here, right? So what's that mean? That means I have a series. So basically they tell you, see here, you have some type of the series, right? So case 1 to n, you add, see here, you add to the n terms here, okay? So then you add this ak, so this is 2 minus 3 point a to the nth power. So I want to see if, find the sum of this series. So basically I'm taking the limit n approach to infinity Sn. That means it's the limit n approach to infinity. This is 2 minus 3 point a to the nth power. So from the calculus 1, we know if you take the limit just by the number will be 2, right? So just then this will be limit n approach to infinity 3 times point a to the nth power. So this will be limit, then you take the 3 out. So this is the limit n approach to infinity point a to the nth power. As you can see, because point h, right? So when you get the exponents, get the power bigger and bigger, what is the whole thing going to become to? Will become to 0, right? Because it's point a times the square, cube, force, it will become smaller and smaller. So what is here? So the answer is 2. That means for this So that means for this series from 1 to infinity to the an, so what I have here, I have 2, right? That's because of my partial sums here. Okay, let's take a look at part B here. So if my partial sum is like n squared minus 1, and this is 4n squared plus 1, see here. Remember, this is a partial sum. That means I have some series, right? So from k from 1 to n, ak. When you add them up, this will be n squared minus 1, 4n squared plus 1. So I want to find the sum of this series. So I will take the limit n approach to infinity Sn. So what is Sn here? So it's the limit n approach to infinity. So this is n squared minus 1, 4n squared plus 1 here. So remember what we did in the previous. So because they have the same exponents, the degrees, right? So we can divide by n squared. So this will be 1 minus n squared. Then this will be 4 plus 1 over n squared. So from here to here, what I did here, I was doing the divide n squared both on the numerator and the denominator. Correct? Okay, now if you add the n approach to infinity, so what happened to here? That means your denominator get bigger and bigger and the numerator is a constant. So here, what happened here? This will give us 0. So the same way is here, that means the denominator will get bigger and bigger. So what happens here? This one equal to 0. So I know what is the limit of Sn? is 1/4, right? So what's that mean? That means this series, if you say n from 1 to infinity, the an, this series will add up to be 1/4 here. Okay, so that's what we mean the partial sums here. And now let's take a look at the part B, group 2's here. So the group 2, they want us to calculate the first 8 terms of the sequence of the partial sum. And these ones here, right now, you look at does it appear converging or divergence here, right? So the purpose for this exercise here, right? It's not, it's kind of like tedious, but I guess the point is they want to drive in the concept of the partial sum. In fact, is, you turn a series become like kind of a sequence because you use the partial sum of the series here. Okay, so let's do some of them, and so we'll give you ideas, right? So this is the series, okay? So from the n is to 1 to infinity, right? So this is 1 over square roots of the n to the 3rd, all right? So what, okay, so let's try to take a look here, right? So like I said, this is kind of tedious, but I think it does have a point because we want to know the differences between series and the sequence. And what is the partial sum means here, right? So now I said S1s here, that means what? You just add N1s, right? So in here we can say the AN is equal to what? AN is 1 over n to the cube roots, right? So A1 is just A1 just 1 over cube roots of the 1, so it's 1. So now let's take a look what is S2 here, right? So S2 is just S1 plus the next terms A2, right? So it will be 1 plus A2. What is A2? That means 1 over 2 to the cube roots. So this number is very close to 1.79 what? 37. Okay, let's take a look again. So S3 is here, right? So S3 will just be the S2 plus what? A3 is here, right? So now you plug it in the same thing. You can say 1.7937, then plus 1 over what? 3 to the cube. What is this one will give you? So this one will give you not equal, I guess, you can say this one's here will approximately to what? S3 will be 2.4a, 2.4a71. Okay, let's do one more, right? So I guess you can get the idea. So S3 will be S4 equal to S3 plus A4, right? So it will be kind of equal to like a 2.4a71. Plus 1 over 4 to the cube roots. So what is we're going to give you? We'll give you 3.1170. So I assume you'll be able to go da, 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 right? So here I go to da, 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 da. So SA, I can approximately to 5.2749. 5.2749 here. Right, so that's what we mean. The partial sum cannot become a sequence. It become 1.7937, 2.4a71, and 3.1170, and da 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 to what? 5.2749. Right, so this is the first A sum. Of course, as you can see, it's kind of getting bigger and bigger. So it's a kind of, you feel like, so this series is what? Is a divergence, right? Right, so because you see like the numbers are getting bigger and bigger and bigger, right? Okay, so now let's take a look at the other ones here, right? Let's take a look at part B here. So this is the summations and n from 1 to infinity. So this is n factorial. All right, so this is -1 and -1 here. So let's do the same here, right? So basically, this is kind of like, you know, your an is what? It's n factorial, and this is -1 to the n-1. Okay, so let's try to do this mechanical work again. So this S1 is equal to A1. So this is the 1 factorial, -1 to the 0 power. So what is 1 here is 1. Okay, now let's S2. So S2 is S1 plus A2 here, right? So S1 is 1, A2 is 2 factorial, and the -1 to the 2 minus 1, so it's -1. So what is the, so this will be equal to 0.5. See here, let's do a couple more. So S3, just like we did before, is S2 plus A3. So this is 0.5 plus what is 3 factorial, -1, 3 minus 1. So it's 0.5 plus 1 over 3 factorials, right? So it's, what is these numbers here? So this is kind of close to 0.666667. Okay, let's take a look at one more. So this is S4 here, right? So this is S3 plus A4. So it's similar to 0.6667 plus A4 is 4 factorial, -1, 4 minus 1, right? So S4 is equal to 0.625 here. So if you go, you know, if you know, I assume you, so let me just write down the numbers here. I assume you know how to continue doing that, right? So this is 0.6333, and S6 is here is 0.6319, and S7 here is close to 0.63, so this is close to, right? 0.6321, and SA is close to 0.6321. So that's why you create a sequences, right? So your sequence start with 1.5, 66667, 6625, and to the 6.6321s, right? So looks this sequences here, you know, it looks like those values, they all kind of what approach to the 6321s, right? So looks like what? So this is a series. This series is what appears to be what converges, right? So of course, you know, like right now we are just kind of like look from the, you know, the partial sum point, but you know, so later we're going to show several different methods. We can mathematically show, hey, this is you know, this is a convergent series or this is a divergent series, right? And right now we just use a partial sum. We kind of eyeball that, and then we say, oh, the problem A obviously is getting bigger, so it must be diverge. And then problem B, you say, hey, the A's partial sum seems to be all very close to the 6321, right? So maybe it is converging. So that's why we say this series appears. That's why the problem say appears to be convergence here. And then we have many different methods later. We're going to practice to show you how to mathematically prove is convergent or divergence. Okay. Okay. So now I think I like to stop these videos here. So we only did like 4 problems about the partial sum, but it's a kind of very important concept to introduce to the series, right? Okay, so I'm going to stop here. So the part 2 of this practice, we're going to focus on the geometric series. Okay, so how to identify geometric series is a convergent or divergent, and we're going to practice 6 problems here. So, okay, so I guess I will see you in the part 2 of the practice. number 4 here. So remember, practicing, practicing, practicing. That's the key to be successful in math. Okay, nice talk to you, and looking forward to see you come to visit my next videos here. Okay, bye.